This is a forced CNC Makerfab 4x8 router. It's got the standard router head on there, and it's got a MDF table. There are some machines out there that have a vacuum table and a high frequency spindle. Those would be upgrades that you could get for this machine if you ever wanted in the future. But this setup is perfect for cutting sheets of plywood out, carving into them. Reasons you might upgrade in the future would just be sometimes the vacuum bed is a little bit easier to hold things down, but the way that they put these T-slots in here now makes it simple to clamp things, so I wouldn't anticipate you necessarily need to. And if all you're going to do is cut plywood like this or other pieces of wood, you don't necessarily need the high frequency spindle. So this is a perfect machine for this type of shop, in my opinion. The first thing I like to talk about is the safety of the machine. So of course there's a number of considerations when we're using the machine. Want to be mindful of having people rest their hands on the machine. You know, really a lot of times people might tape off an area around the machine, so when it's in use, people should be outside of the area, because you don't want somebody here having a conversation, having their hand on it, and then the machine comes over, because it can cause some damage to your hands. Obviously we have a bit inside of the router head that's going to be rotating, so safety eyewear is highly recommended, really required, because something could come flying off the table. So we want to make sure that we're mindful of that. And really it's just kind of common sense stuff. You don't want to have loose clothing, you don't want to have long hair near this machine. Just people who are near the machine while it's in use should be paying attention to the machine, not other things. So I would recommend maybe putting something on the floor to have people understand that the machine is something they should be aware of while it's running. We'll get into the maintenance of the machine in a little more detail. Let's talk through what's in the starter kit. All of these machines will come with something that says the name of the router and the starter kit. And what we have in here, this is a tool touch-off. We'll demonstrate the use of this later. We have some various bits in the machine that come with it, just different standard sizes. These can be reordered if they break, but you can buy bits from anywhere. It doesn't have to be the bits that Forrest supplies, but many people, this is all they really need, and if something breaks, it's easy to reorder right through us for Forrest. These are the actual wrenches that are used to loosen the collet nut, take the bits out and replace them. And then you've got your common Allen that's used in various spots on the machine that tighten things down. The other thing that comes with the machine is this grease gun. And this is already set up with grease in it. The important thing about this grease gun is there's a very specific grease that is recommended to use with this machine. You don't want to mix different types of grease, because that'll result in an epoxy forming, and so you'll pump in a different grease and all of a sudden it locks up the bearings. So when the time comes to run out of grease, look at the container that's in there and reorder the exact thing that's in there. If you have any questions about that, you can contact us and we can help you figure out what you need. And Forrest, while they don't make the grease, they do have the grease in stock, so you want to make sure that you're buying and replacing the grease that's in here with the exact grease that comes with the machine, otherwise it can cause problems. And we'll demonstrate greasing the machine later. The machine is currently on. I'm going to turn it off to show that boot up process. First of all, this computer was supplied with the machine. You see a note on here that's warning you not to change anything about the machine. They really put that fee on there as a warning, because the IT gets their hands on the laptop, they reformat it, and it's a bit of an issue to log back in and get this cleaned up. So they want to make sure that if IT comes in and sees this machine, that they don't make changes to it. Make a phone call. They put the phone number right on here if there's any questions. So this computer should stay with this machine because it's got everything installed on it already to work. This is our control box. It's plugged in already, so I'm going to press the green button to turn it on, and that'll boot up the control. And this particular control connects to the computer via Ethernet. So in order to access the internet, we're on Wi-Fi, and then the control is going to communicate with the computer via Ethernet. So it's important that the IP address settings on this computer stay the same. If that gets changed, it's not a huge deal. We can remote in and assist with that, but that's the biggest issue with communication, is if the IP address settings for Ethernet port get changed and it no longer can talk. Once this boots up, we are going to open the control software. So it says router control up here. That's the control software. And it should say establishing communication. If you are going to have an issue with communication, it'll give you an error right there. When this boots up the first time, it's going to say reset initiated, press reset to clear. So that's this button right here. I'm just going to press reset, and now it's cleared that. That's, I guess, a safety mechanism, just forcing somebody to provide input before the machine can move to verify that there is a user here and they do intend to use the machine. The other thing that can happen is if your e-stop is pressed in, it's going to tell you emergency stop detected. This is a twist, so we'll just twist it to turn it, and that should show that the e-stop has now been released. The next thing that we like to do, first when the machine has started up, is home the machine. So we can see up here, X, Y, and Z are all blank. That means the machine has no idea where it is in space. There are homing switches on the X, Y, and Z axis that need to be tripped, and once they're tripped, the machine knows exactly where it is in space and therefore knows how far it needs to travel to get to the position that you want it to get to start the program. This is our X axis right here, and this is the X axis homing switch.
Right.
This is our Y axis in this direction. This is our Y axis homing switch, and our Z axis is here. You could technically change that in the back end of the software if you wanted it, but it's set up right now so that the arrow keys on the keyboard are going to move it in the direction you would expect. There is a button up here that allows us to home the machine. The recommendation is to actually first jog the machine generally to where the homing position is, which is where the machine is currently right now, because if I press this reset home button, it takes a very long time. It jogs at its slowest speed. So I don't want to have the machine out here and then hit reset home. It'll take all day long for it to slowly jog back. So what we can do instead, let me demonstrate this. If the machine is out here, we can jog the machine without the machine being homed. But if I hit reset home right now, you can see how slowly it travels. So you can imagine how long it would take if the machine were out here. I'm going to hit, it tells me right here, hit cycle cancel to cancel it. So I'm going to cancel that home. And now I'm going to just jog this very close to the limit switches. We don't really need to do Z, but we also want to make sure that none of the limit switches have been tripped before we tell it to home, because then it's also going to be confused. So I'm going to jog it pretty much all the way back. And now that I'm very close to the home position, I'll hit reset home. And now the process is going to go much faster because we're pretty much in the position we need to be in. Once that completes, you'll see zeros appear. Well, the zeros are here. This is actually its current position compared to the work offset that was previously set. So the machine coordinates are 0, 0, 0. Now we're able to actually send a file to the machine, and then the next step would be to set up the work offset, so where we're actually going to start the part on the table. The spindle or router, it's actually it should be I believe a 3.5 horsepower router. Since it's not the high frequency spindle, you actually need to make sure the router is turned on. So right now it's actually in the off position. It won't start like this. So I'm going to flip the switch here, and then there's a speed control here, just like a handheld router. There's an on-off and there's a speed control. This is how we control the speed. The software, even though there are settings in the software that try to tell the machine how fast to spin the spindle, this spindle doesn't support that. You're going to control it via the actual router itself. So one mistake people make is they don't realize that that's in the off position, and then they start the job and the machine starts to go, but it never turns the spindle on, and then you have a crash. So it's very important to check and make sure that's on. Some people, for a safety feature, like to turn the spindle off before they change the tool, just to make sure it's just not possible for the spindle to get turned on while you're changing the tool. But it's not completely necessary to do that. But that's a common issue. Somebody turned it off, changed the tool, and forgot to turn it back on. So just make sure that you check that before you start the job for the day. We can test to see if the spindle actually will turn on and off. up here. So if the red light for auto spindle is on, then these on-off switches won't do anything. So right now, it's in auto mode, which means the only way for the spindle to be controlled is via G-code in the program. But if I want to test and make sure that the spindle will turn on and off as expected, I can click that button and I can press this green button. Red button, and that is just manually controlling the spindle. So I've verified that the control has the ability to turn the spindle on and off. And so had we not turned the spindle on there, and I tried that, it wouldn't come on, and that would tell me I need to look into something before I try to run a job.
Important when you do this that it's as straight as possible, or is it somehow going to account for it that's a little skewed?
So, very good question. I was just about to address that. In this case, it doesn't matter because what we're cutting out is significantly smaller than the size of the material we have. So even if this thing were turned all the way like that, as long as where it cuts doesn't run off of the material, what I cut out will be square the way you want it. Where you really need to work to line things up is imagine you bought plaque blanks and you want to engrave right in the middle of the plaque blank. Well, I can't cut out of that material. I want it perfectly centered. In that case, you need a way to align the material to the travel of the machine so that when you cut it out, the text isn't on an angle or not centered perfectly. So there are a number of ways to accomplish that. You could set up a fixture. What I would probably do in that case is actually mount a piece of wood to the table and then pocket out something that's the exact size or slightly bigger than the plaque. And now as long as the material that I cut it out of stays clamped in the exact same spot, I know I can butt that plaque up into the corner and that it's going to be perfectly aligned to the travel of the machine. That would probably be the easiest way. If I'm doing mass producing, I'm going to go to that level of effort. It's going to be much easier. If I'm just doing one of them, I would probably mount the plaque using clamps or something like that, and then you could jog the machine to one corner of the plaque, and then without moving this direction, go up, come down to the other corner, go down, and then adjust the plaque up and down so that both corners are in the same spot where the machine travels. And then I can measure left to right and then center it. And if I'm only doing a single, I wouldn't want to do that with every single one I'm doing, but if I'm only doing one plaque, that's how I get around that. In the case of this, we've got what we're cutting out is so much smaller than the piece we have that even if this were turned like that, you wouldn't notice it in the end, other than the fact that the hole that we cut out of this would be skewed. So if you're trying to use this material for other things, then you want to try to be a little bit accurate. In this case, we're just sort of going to idle, and it'll be good enough for our purposes here today. So we've got these. Now, say we wanted to cut all the way through this. Could you cut through this into the bed? Sure, you could. You really don't want to cut into these slots here. So what we would ideally have is another piece of material that's more or less the exact same size as this, and we would just sit it on top of this, clamp them both to the table. And then when I cut through the first piece, it's going to cut into a second piece that's kind of our sacrificial bed. So that's the easiest, quickest way to do that. Some people will actually mount to the table an entire second piece of MDF, depending on how, most people don't end up using the whole 4x8 bed. You're usually only cutting small things, and every once in a while you need the whole bed. But you might get a 4x4 piece of MDF from Home Depot, clamp it down somewhere on the table, and then plane the top off using, actually a flattening bit. Now you got a nice flat sacrificial bed that's clamped down, and then you can just screw parts down to that. And if I cut through, then eventually I replace that, or I flip it over and eventually replace it. So it comes down to how often you're doing projects like that as far as what you want to do. Okay. This is VCarve Pro. As we discussed, it supports unlimited table size, so you can do your whole 4x8 no problem with this. There's just an icon on it on the desk, or icon for it on the desktop, and we're just going to go up to File, New. The job setup, typically how I handle this is I measure the material that I'm going to cut and I enter all of that information. I don't put 4x8 here. You could do it that way, but it's easier in my opinion if we actually measure the material. So you got a tape for that? And so the x-axis is going to depend on how we put it on the table. So right now, the x-axis is that length and the y-axis is this one. And we can, it may be easier to actually mount it this way just because now we've got more slots to work with.
How accurate?
Pretty close. 12 and a quarter. So that's our y.
And
12.
36.
36. And then what's our thickness there?
It should be, well, it's 3/4, but it's always a little less than 3/4.
Well, if it's a little less, we'll enter 3/4 and it'll just cut through. We probably won't cut through. We'll talk about that in a little bit. All right, so I've got that information entered here. The next option is going to be our Z0 position. The options are material surface and material bed. There's really no scenario that I can think of off the top of my head where you're really going to pick anything other than material surface, because we're going to want to touch the top of the material. And then our datum position, that's a very important selection. Most people will select the bottom left corner here because it's the easiest part of the material to reach with the machine. Correct. There are some cases where you might want to use the center for the datum position, primarily if I'm going to do a two-sided part. Probably not going to be something you're commonly doing with this type of machine, but you can imagine maybe you want to do a guitar body, and so you got to cut both sides of it. Well, there needs to be a way to flip it over and have the datum position in the same spot, and so the center is the way to accomplish that. If I pick the bottom left corner and then I flip it, well, now the bottom left is the top left. And so what I would do if I were doing a guitar body is, that's a little outside of the scope of what we're trying to accomplish here today. Right. But you would need a way to have a fixture there and maybe some pins that it's resting on, so you can slide it off, flip it over, and put it down, and it's square to the travel of the machine. So it's a little more complicated, but definitely something you could do with this machine as you get more advanced with it. For now, we're going to focus on single-sided, simple parts, and in that case, the bottom left corner is just really the simplest place to pick it. So the red icon on the screen here is going to indicate where that datum is, so that's a reminder for you for when you go to jog it. Okay, right, bottom left, that's where I need to find it. Once we're done there, we're going to hit OK. And now we can start drawing. So very basic drawing tools available. This is considered sort of a CAD CAM package, which means that you can do the full design and setup in one software. Now, if you're using AutoCAD, if you're using Inventor, if you've got other CAD packages that you prefer, you can absolutely design in them, and then you can import files into this software as a DXF or another format and just skip using the design tools in here if that's your preference. But most people like the single interface. It's just one software to teach, and it can kind of do the whole thing. All right, we'll start with some basic design. I'm just going to draw a rectangle, so I'm going to go over here, and I can enter in the anchor point if I want to. So say I know I want it to start at 0, 12. I can select the top left corner is going to be at X0 and Y12, and then I could say I want it to be a 6-inch by 3 or 4-inch rectangle and hit create, and there it shows up like that. I can use the different handles, rotate it. You can always hit Control Z to undo anything you did. I can drag it wherever I want, and then I can also Does
that give you dimensions of the box while you're
now
adjusting?
If I want those dimensions back, then what I need to do is click on it. So I'm clicking the outside and go back to that tool.
Okay.
And once I'm in there, I can actually enter in specific dimensions again. So 6 by 4, and then hit apply, and it updates.
Okay.
So if you're just
So
doing
it'll keep it in the relative same position, but change it to the exact size you want it to be.
Right.
Okay.
So I'll draw a circle now. Same process, select the tool. I can either enter in a radius, or I can go out here and just draw something and apply and close. Well, I may want to do a couple of things here. I may want to center this rectangle on my material. If I want to place the rectangle perfectly in the center of the material, well, I could know the width and the height of the material, and then I could go back in and tell it to move to exactly where that is, but there's an easier way to accomplish that, and that's with these alignment tools. So I'm going to go to Align Selected Objects, and first I have to have something selected that I want to align. So I've selected the rectangle. The top 3 buttons here allow me to align what I've selected to the material being the sheet here. So if I wanted to center this material on the sheet, I can center it left, right, I can center it top down, or hit Control Z a couple times to undo that. I can press this one button and center it left, right, top down in one go. Now that material or that box is centered on my material. The other thing I may want to do is move things relative to another object, so 2 objects relative to each other. So to demonstrate that, I'll move that out of center. That's this set of tools here, Align to Selection. I may want to align this circle relative to this box, or I may want to align the box relative to the circle. It depends on which one I want to have move. If I want the circle to move relative to the square, then you can read here, Align Selected Objects to the last item in the selection. So I'm going to select both of them by holding either Control or Shift. It's of course always the second one. So select the circle, hold Shift, select the rectangle. Now both are selected. The rectangle was selected second. So now these tools will move the circle relative to the rectangle. And again, same thing here. I also can use these buttons to align them to edges or outside edges, whatever you need. All of these tools do that. If I undo all of that, a bunch of Control Z's here. If I want the square to move relative to the circle, then I need to select the circle last. So select the square, hold Shift, select the circle, and then the square moves relative to the circle. So it just depends on the order of the selection, what you want to have accomplished. Those tools come in handy when you're doing your design work. So we'll leave that for now. And then I'm going to double click on here and I'm going to drag this just a little bit bigger so we can add some text. I'm going to hover over the text tool. You see it says draw text. And I will type, do you go with HHS?
Howard High School?
Yeah.
HHST.
HHST. There we go. HHST. We don't need to do a whole script, but I will use a script actually because it'll help us demonstrate the V-bit we're going to do in a little bit. Find a decent text for a V-bit. That should still be fine. Just scale that down. So I can stretch the text left and right, make it fit. And then there are some snap features you can enable, so you can see it's sort of snapping as I drag it around, but I can also go back to what I was doing earlier, and that's going to be select the text, hold Shift, select the square, go to my alignment, and I'm going to align it left, right. Now in this case, I don't really want it centered, right? Because I've got that circle there. So I'll select it and I can use the keys on the keyboard and just tap down, and this is just sliding it down to what I like, what I think looks good. So we've got 3 elements here that we can use to produce our part. Next step after we have created our graphic is to set the job up to run the part. There's the drawing tab, which is what we've been on, and then on the right hand side there's something called the toolpath tab, and I can just hover it here and it will open. What I can do is I can pin this one and then unpin this one. Well, I guess I didn't pin that one. Press the pin here and keep it open. but there's an easier way as well. This button right here will do what I just did for me. So if I press this button, it unpins the toolpath tab, opens the drawing tab, and pins it. So generally what I do to switch back and forth is just press these buttons back and forth. So I'm done with my drawing tab. I want to go to my toolpath tab. It's opened this for me. We're going to use 3 processes here just to demonstrate the 3 most common processes that you're going to use. We'll first start with a pocket toolpath. So a pocket toolpath, of course, is going to take geometry that I've selected, like this circle here, and it's going to allow me to remove all the material either on the outside or the inside of the geometry I've selected. I first need to specify how deep I want it to go. We're going to keep things shallow just for time and less sawdust in the air and all those good things, since we don't really have this is just a demo part. And I need to select the tool I want to use. So there's a default end mill here. I can go to edit and edit the end mill if maybe it's different than the one that I think I'm using. I can go to select and pick from the library. It looks like somebody did set up a tool list here for 4 CNC tools, but there's only a single tool listed in it. I would recommend going through the tools that you have and creating a folder for them and getting rid of everything else. That way students don't get confused about what's available. It is important to make sure that you're selecting the right tools, because if student picks something they think is a 1/4 inch end mill, but it's really a 1/8 inch ball, then all the tool paths get calculated incorrectly, the feeds and speeds get calculated incorrectly. So you can imagine trying to run through material very deep into the material with a small bit is going to break the bit, and then something's going to go flying. So having the correct tool selected that you're actually using is important for a number of reasons. In this case, we're going to use an 1/4 inch end mill. You'll see there's also a 1/4 inch ball nose. So the end mill and ball nose, the ball nose is a rounded bit, the end mill is flat. You guys probably know this from using these types of bits in routers. Pretty much standard router bits are what you use here. You aren't using a drill. A drill is only going to cut going down. It's an actual router bit which allows you to cut laterally as well. So the cutting blades aren't just to go down, they're left and right. I have had people put a drill bit into a machine like this, and then they try to run this way. Well, you're not cutting anything, and you'll see smoke, you'll hear chatter, stuff's going to break and go flying. Yeah, so all these are actually router bits that can cut laterally, which is what we need.
That's a ball bit.
Yeah, there
That's
you go.
Around
He's not a carpenter.
the tech guy.
So that's an end mill, and that's a round.
That's named very nicely.
Yeah, it makes it easy. If you use I guess the easiest way to describe when you might want to use one versus the other, if I want a nice flat bottom, the tool needs to be flat.
Yeah.
If the tool's rounded, then I'm going to get ridges as it goes back and forth, and I'm going to have to clean those up. Will it pocket it out? Yeah, it will, but the bottom won't be perfectly flat. If I'm doing a 3D contour like that what was that, an eagle over there?
Yeah.
Does that have stair stepping in it? Can you see?
I think that was actually done with the little cut.
Yeah,
Oh, really?
It's got a little bit.
Okay, well that could have been an
But
engraving
it's
bit, and if it was, that would have taken all day.
I think it might be the one that's on there, because that may have.
So-
that would say it took a long time.
If you're doing 3D contours like that, that's where a ball end mill comes in handy, because it won't leave ridges. If you try to do that with a flat end mill, then everywhere where it's not perfectly flat, you're going to have stair stepping like you might see on a 3D printed part.
Yeah.
On an angle. It's going to be like that on the curves, whereas a ball nose can get in there. Now the smaller the ball, or the smaller the tool, the more detail you can get out of it. So if you're using a sharp pointed bit like an engraving bit or a V bit, you can get all those little details, but it's going to take all day long, maybe multiple days, to cut a big part out that way. So that's always a balance between speed and the level of detail that you want to achieve for that type of part. In this case, we're going to keep things simple. We're going to click on the end mill here, and we do need to address the tool numbers. You don't have an auto tool changer on this machine. However, the software can get confused if I give both different bits a different tool number. Tool numbers don't really matter in this case, but I just need to make sure that the bits that I put into this program have different tool numbers. So if I said that this is tool number 1, but I also said that the other bit we're going to use, the V bit, is also tool number 1, it's going to get confused in the post processor. So best practice would be to make sure that that tool number is different. You could make it tool 7 and 12, it doesn't matter as long as they're not the same. Really what I would recommend is, like I said, add all the tools in that you have, and we can do that today just to set that up. We can back up the library, and then you can put it on other computers, and that way when the students are setting up jobs, they've got the same setup out here. They're not picking different tools and you have no idea what they are.
Label it so that
Yeah, and then what I would do is
label and then the number that they should be using if that's the one they want.
and make a project where the students actually engrave. They'll cut out cut out holes, and you can put the tools in the hole and then engrave the tool number on it, so the tools are sitting there. Right. Tool number 1's already set up, and then we've got that library here. You can put on every other computer, and it's only got the tools that you're using on the machine. So we'll go through that a little bit later. For now, we're gonna pick. Was that a 1/4" end mill? Did you think? Okay, yeah. So we'll since we have that, that's what we're gonna use here. I'm gonna select the tool. For the pocket toolpath, there can be multiple tools in here for some reason. I haven't quite figured out why, but we want to make sure we only have the one we selected. Then we are going to do offset or raster. You can just see, I mean, it is pretty self-explanatory. If I click on raster, you can see what it's going to do versus offset. Typically, I'm going to leave it as offset. And then you've got conventional versus climb. That's sort of the direction that the bit is spinning, and therefore the direction it's cutting versus the direction it's traveling. So you get sort of different grains of looking on the wood if you cut one direction versus the other. Just like cutting the grass, you see go this way and the grass looks a little bit different. So this really doesn't affect the cut, but it affects maybe the finish of the part depending on the material you're using. I don't usually make a change there. Once we've made our selections, which in this case could have been as simple as setting the depth and selecting the tool, we go down and we just make sure that the geometry that we want to process is selected, and you can tell it's selected because it's pink and sort of dotted line, and hit calculate. Now it's going to generate the toolpath for it. If I want to preview that toolpath, I can say preview, and then I can rotate this around and see what that's going to look like in our material before we run the job. So that's shown up now in our toolpaths, pocket 1. We can name that whatever we want. The default's just pocket because that's the process in a 1 because it's the first one we made. But if I wanted to make it a really complicated job, I might name this, 1/8" circle pocket, whatever. Just that way, when this gets really long and you need to make an edit to it, because we can go back and edit anything we've already done. I don't have to click around a million times to find the one I want. I've already got it named. If I wanted to rename it, I just right click on it and rename it. If I want to go back in and edit it, I just right click on and hit edit, and I can go right back in here and make a change to it and recalculate it. Maybe I really wanted to go deeper. I could go in here and say, this is now 0.2, and then I have to click calculate again, and it will update everything for me. We don't want to make a change here, so I'm going to hit cancel. We want to actually add to this. So we're in now the 3D view. You can see this tab, 3D view is open. I'm going to go to 2D view now, and I'm going to make my next selection. I'm going to select the outline here. Now, if we were going to cut all the way through, I'd recommend doing the outline last because, obviously once you cut through all the way, part could go flying out, and we'll address that in a second as well. Since we aren't going to cut through, I'm going to do this second because I want to minimize my tool changes. We're going to use both the 1/4" end mill for the pocket and the profile, so that way the machine doesn't need to change tools. And then we're going to use a V bit for the text, so we're going to do the pocket, the profile. It's going to prompt us to change the tool, and then we'll finish with the text. I could certainly do the text second, but if I did that, I'd need the 1/4" end mill for the first process. I'd have to change the tool, and then when that's done, I have to change the tool back. So I want to minimize the tool changes. So you're just thinking about how often you need to do that. If I were cutting this out, really what I would do is probably the text first. In fact, we probably will do it first because the V bit's already in, and therefore we don't have to change that out. And we can reorder everything after the fact. So I'm going to select the profile here, or the outline here, and I'm going to go, previously we went to pocket. I'm going to go to profile next and click this button. And then again, I can select the depth. It's defaulting to 0.78. Maybe that was something somebody typed in previously. That is slightly thicker than what we had told it the material was. So if I were going to, first of all, we'll make sure we've got our bits selected here, and it's still tool number 1, and it's our 1/4" end mill, so I made sure that that's the correct bit. It is telling us it's going to take 3 passes to cut down the 0.78, and where it's getting that from is our pass depth is set to 0.26, which is a little aggressive. Generally, it's a percentage of the tool diameter, and it's not usually over 100% of the tool diameter. Depends on the material. The softer the material, the deeper you can go into it in a single pass. I like to use a lot of grass cutting analogies when talking about these machines. So imagine you didn't cut your grass for weeks, and you get out there with the lawnmower, and that first pass through the grass, you've got 100% grass load on the lawnmower blade, and it's really bogging down because you went down to your normal depth cutting the grass. That first pass is going to be the hardest on the lawnmower because I've got a whole row of grass that's under there. But the next pass, I don't have to move the lawnmower over the whole width of the lawnmower. I can go less. That's one way to compensate for the fact that the grass is really high. I also could raise the blade up, so I'm not taking off as much grass and then go down and lower the blade a second time, take a little more grass off. That's another way to compensate for the fact that I'm really trying to take off more grass than the lawnmower is powerful enough to do. The same concept applies for the tool. The bigger the lawnmower, the more powerful it is, the more I can take off with faster speed. The bigger the bit I put on there, the more aggressive I can be as far as material I'm removing. But there's still a limit to all that. There's a whole, if you go online and you look up CNC tool load theory, you can find books on how to calculate chip load and all that stuff, because in production environments, that's the name of the game. I want to make parts as fast as I possibly can all day long, and there's wear on the tool, and I can go fast, but it may wear down expensive tooling faster than it needs to. So everyone in production environment is living on the very edge of what they can get away with in that regard. In the case of education and just cutting parts out, you tend to be a little less aggressive on the stuff because whatever, I'm going to cut 3 parts today, and if it takes 25 minutes instead of 15 minutes, I don't care. But that's where all this stuff comes in. You're concerned about safety and kids not breaking stuff. So in that case, I tend to be a little more conservative with the numbers. I would say there's really a, I don't know where this number is necessarily coming from. See, you can see here the ball nose is set to 0.6 inches of pass depth. Maybe that's just the default settings for wood. I don't remember. But that's how it's calculating the number of total passes. We told it needs to go to 0.78 inches deep. We told it this tool is allowed to go 0.26 inches per pass. So therefore, it's going to take 3 passes to get to that depth that we want. The feed rate down here, this is what I was talking about before. If you had a high frequency spindle, this number would actually control, or sorry about that, the spindle speed. If you had a high frequency spindle, this number would control how quickly the spindle's running, but that's not controlled with this type of router. Even though the option's there in the software, you can type whatever you want and the spindle's going to go as fast as you have the setting on the router. So just ignore that setting. The feed rate right here, 75 inches per minute, that's how quickly the machine is going to travel as it's moving. The faster we try to go, again, just like the lawn, if I try to run through my grass, it's going to be a lot harder on the lawnmower than if I go slowly. Again, another way to compensate is go slower through the material. So the pass depth, the size of the tooling, and how quickly you travel through the material, as well as how quickly the spindle is turning, all go together to determine how quickly I can process something. What you should do is listen to the machine. If I'm going too quickly, I'm going to generally hear chatter. You're going to hear the tool trying harder. It won't sound as smooth. It's going to be loud no matter what. But if you hear this chattering, kind of choppy noise while you're cutting, generally you're probably going too deep, too fast, too small of a bit. If you hear a bang noise and then clink, 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 because the tool went flying around the room, then you definitely know you did something wrong. And that's where the safety glasses come in handy.
And you can so you hear the chattering. Can you pause it and change that speed, or do you have to reset the whole thing?
Some machines, there's an override knob that allows you just to slow it down. This machine doesn't have that. There may be a way in the software to do it. There's definitely, you could either directly edit the G code and just go back in and type a different feed rate, or you could come back in here and reprocess the job at a slower speed and just record the line it stopped on and restart from there.
Okay.
There's a couple of different ways you could do it, but yeah, I would probably pause the job if I'm hearing a lot of that. On the other side, if I'm going really slow and spinning the material, you know, the tool is spinning, so imagine you're trying to start a fire, right? You might see smoke. So if you start to see smoking, smelling that, you may be running too slowly through the material and the spindle is just spinning on it. Another reason that could happen is dull bit. So it's no longer cutting, it's more just like wearing it down, grinding it down, and you'll hear chatter when you do that, but you also smoke. The bit will start getting really dark and nasty. Those are indicators that maybe the bit is dull or has been damaged in some way. So just watching, listening to the machine, you'll get used to what it sounds like when it's cutting properly, and then you'll know when something's off. You may not know the exact settings, but go slower if it's chattering, and maybe check the bit if it's smoking or the cut is really rough looking, comes out. Those are things to check on. 75 inches per minute for wood. I mean, you could probably run much faster than that. That's a conservative number. I've seen 100. I've seen some people run at 200, but they might be really dialing their machine in. They might not be running as deep. They want to run quickly. There's different reasons. Again, it comes down to finish as well. How much time do you want to put into sanding after the fact? The balance that people have in education is you may run with a bigger bit than you really want to if you were doing this as a personal project, because you need 12 students to get through this machine today. So they're going to have to do some sanding when they're done, but we can get each project off the machine faster because we're using a bigger bit, and therefore we can cut the cycle time down in half, basically. So you say, yeah, you know what, that would look better if you used a smaller bit. You're just going to have to deal with less detail because we want to get everyone's job done, not just yours today. Whereas if you're doing a project for the school and putting a big, beautiful sign up, then you're going to change the way that you approach designing in that environment. All right, we've got that selected. I am going to simulate cutting through this. We're obviously not going to do that because we don't want to cut into your table. We'll talk about what we can do if you did want to cut all the way through. I have a couple more options here. Outside, right, inside, left. So what do I want to use this line for? If I've drawn this, say this is 5x5, and the thing I want to have come out is 5x5, I need to make sure I've selected outside, because then the entire tool is going to be outside this line, leaving the exact size. If I selected inside right, well, now it's still going to use the same geometry, but the tool is going to travel to the inside of it, and the size that you're ultimately going to get is going to be smaller by twice the diameter of the bit, because the bit's going to be traveling on the inside of it. Also, it would end up cutting off our text. There are times that you may want to do that. Maybe what you actually want is the machine with a hole, or the part with a hole in the middle of it, and that hole needs to be the size you've drawn. Then I'm going to do inside. But if I want the actual part that I'm cutting out of it, then I tend to do outside. You could also do online, but that's going to reduce the size of the part by twice the radius of the tool, so therefore the diameter of the tool. These selections just come down to understanding what's going on and what you want out of it, and the best way to learn this stuff tends to be mess around with it, see why it didn't work, and then change some settings until it does work, and now you get it. If we are going to cut this part out, we would need to add what's called tabs. And tabs are added here, so you can see add tabs to toolpath. That's this selection box. How wide do I want the tab and how thick do I want the tab? And I'll click edit tabs here. And what I can do, I can either add constant number around, or I can, I'll hit delete all tabs now. I can just hover over the part, and when I see a check mark, I can click and put tabs wherever I want. The point of the tab is to leave a little bit of material. So that way when it cuts the part out, the part's still connected to the overall part. It doesn't go flying out. If you cut all the way through something and it gets to the end and then you didn't add tabs, the part's going to go flying out, because what's going to happen is right when it finishes cutting it out, it's probably going to shift a little bit. That spindle's going to be turning it at thousands of RPM, and then the bit's going to grab it and shoot it across the room or run it into the bit. You'll throw it at somebody and your part will be completely destroyed, because it's going to have a giant cut out of it. You can break the bit. All sorts of bad things can happen. Every once in a while you get really lucky and it stays where it was supposed to, but if you're doing thicker, more aggressive cuts, it tends to go flying out of the machine. So that's what tabs are for, and then we'll show you what that results in. Now, if I hover over a tab that I no longer want, I can just click on it, or I can click delete all tabs. I can tell it how many tabs I want, 3 or 4, whatever. Usually 2 is enough in most cases. Depends on how big the part is and how big the tabs are. We do typically want to try to make the tabs as small as possible because you got to get in there, saw it out, and then sand it off. And I try to do it in flat areas, not rounded areas, because it's easier to sand it down when you're done if it's in a flat area of the part. So we got our tabs here. Hit close, and that's really the last selection. You can spend time going through all these other types of things if you want to, but they're very uncommon for this type of project. And then I'm gonna hit calculate, and what's gonna happen now is it's going to warn me. What it's warning me about is the fact that I'm telling it to go thicker than, deeper than the thickness of the material. So it's saying you're gonna cut all the way through if you do this. Are you sure that's what you're going for? Because if you thought you typed in 0.12, but you typed in that, and now you cut into an expensive vacuum bed. It's not a huge deal if you cut into this MDF table, but it can be a big deal in some CNC machines. So this is prompting us, are you absolutely positive that you intend to cut through? Yes. And now I can preview the toolpaths, and I can look here, and there's my tabs. So that's what I would ultimately get. And then I would just cut these out, sand it off, perfect, everything's good. Part didn't go flying, part's in great shape. All right, but we are going to edit that. So I'm gonna right click on this and hit edit because I don't wanna go all the way through. I'm not gonna add tabs, so I'm gonna uncheck that, and we're gonna go 0.1. We'll just go a little bit shallower than the first one, and that's gonna be completed in one pass. Calculate. Now, it did recalculate, but the preview is not updated. I'm gonna go here, and I will reset my preview, and then I'll preview all toolpaths. And that's now what we're gonna result in. As you see, it did not prompt and warn me that we're gonna cut through because we no longer are. All right, so we've got our tool, our pocket one and our profile one. Go back to 2D view, and now I'm gonna select the text. I'm gonna hit close on here, and I'm gonna use my V-bit process for this. All right, so we need to select the V-bit. Let's take a look at what this one is.
There is another one here. There's a.
They're usually double sided. That looks like a 60 degree. If we get that wrong, it just looks a little different than expected. So it looks like a 1/4 inch 60 degree is what we want. It is a different tool, so I'm going to select tool number 2. Again, it doesn't really matter as long as they're different. V-bit, and then that's really all you have to do here. It'll calculate the rest and see what happens here. Yeah, the text is a little bit big for.
Is it pocketing the text?
Yeah, it should. This is actually like a. It looks more like an engraving than a V-bit process. Hold on, let me go back in here and see what. Oh well, it really shouldn't have a. There we go. That's it. Had some option. That's really what it should look like. So see how we view it from the side? It's actually a 3D toolpath. You can see the depth of it. The idea of a V-bit is, and it works better for, like I said, script or really thin text. So imagine we tried to cut a letter into a piece of wood, but the width of the letter was smaller than the 1/4 inch bit we're using. Well, the 1/4 inch bit can't fit within the boundaries of the text we made, so it's just going to skip it altogether. The V-bit can, though, because of course the V-bit can be pulled away from the material, and the deeper we go into the material, the wider it cuts. So a V-bit process is a 3D process because it looks at the width of what it's trying to remove, and it varies the depth that it puts the tool in to vary the width of the path that it cuts out. It works really well for text because I can put really any sort of script. It can have tiny little areas of it, and the V-bit will pull all the way out, so just the very tip of the V is cutting that area, and it will have wider areas, so it plunges deeper in up to the width of the actual bit itself. So the bigger the V-bit, the deeper you can go in there in a single pass. And it will allow you to really put text on anything. I can use a standard 1/4" bit for text if I want to, but every single part of every single letter needs to be wider than the diameter of the bit for that to work. And that doesn't tend to be the case when you're doing, you know, even a small sign like this. If I'm doing a big sign, sure, I can use a regular bit for that, no problem. But if I'm doing smaller letters, the V bit's the way to go. And this is what that process looks like. So I've got that calculated. I'm going to preview what that looks like. And you can see we're going to get our text here. You get this, you know, obviously the path that it cuts out looks like a V as well. So it ends up making a very cool looking design when it's done. Since the V bit's already in there, what I'm going to do is I'm going to move the VCarve up first. So I select the VCarve and I'm going to go up 1, 2. And that way it processes the V bit first. And I don't necessarily have to, that'll reduce the number of tool changes. We just have one. Now that this is done, we'll close out of the preview. This is ultimately what that will end up looking like on the part. And my next step is I need to save the toolpaths. So I can select all the toolpaths here and go over to save. And if I try to do visible toolpaths in one file, so not saving each process as a separate file, it's giving me an error. And it says the visible toolpaths are different tools and the selected post processor doesn't support tool changing. So what that means is the post processor that's selected here, and it even says no ATC, which means no auto tool changer, it doesn't support an auto tool changer, nor does it tell the machine to come forward and change the tool and then continue on. So each process that uses a different tool needs to be its own process. So what I can do is I can export the VCarve bit as a single process here, or single job, and I'm gonna go, I'll just create something on the desktop. Well, there is something called to install elsewhere. Maybe that's got your license file. So I'm going to save the CNC or the VCarve as a single process. These two use the same bit, and since they use the same bit, I can save those both to one file. Does that make sense? Mm-hmm. Save toolpath, and it's calling it pocket because I think that's the first one that's selected. I can name it whatever I want, but I'll leave the default. That actually, even though it's named pocket, it contains both pocket and profile in a single job. So I'll load VCarve, we'll run that, and then we'll load the second one, pocket, and we'll change the tool between. We'll run that one and it'll do the rest of it. And then from there, it's time to set the job up. Import bitmap, H logo, or whatever your bitmap is, and open it. Now it drops it onto your sheet. I'm going to select it, and then I'm going to go to the little bird icon, so you can see there's a little bird inside the folder for import, and then the bird icon here is trace. Now I can do color or black and white, and since this has more than one color in it, we can try color, but you can see all the different colors it's trying to it's detecting in this is up to 16. So I need to tell it what I actually want to trace, but really it looks to me like it's really 3 colors, black, white, and blue. So if I slide that down, I can kind of pick between them, and I can say, well, let's see what happens if I trace these things. And we have to play with this a little bit, and the more grainy the image is, the longer this might take. Before I do this, I can hit preview and kind of see what vectors it's making. Is that capturing everything I want it to capture? It looks pretty close, but I can keep turning things on and off, and I want to turn that color off. Let's see if I turn white on, preview that. I can also go to black and white and hit preview. Black and white tends to work reasonably well because even with the different colors, it's either detecting it as dark enough to qualify as black or light enough to qualify as white. That ends up looking pretty darn close to the outlines that we want to cut. And then what we could do is use a V bit for the whole thing. So if I'm happy with this, and we'll just start there as a starting point and hit apply and OK. You can see the image is actually still underneath it though. So if I double click the image, I can drag it away and then delete it. And now I'm just left with the vector. But I may not want this outline. It used the outline of the actual image itself and created a vector line. So I'm going to right click here and hit ungroup. And then I should be able to separately select that, delete it out, highlight everything again, right click and group. That way it all moves together. Now I've got that. If I wanted to create a V-bit process for it, I'll go over here, click V-bit. I've got the same 60 degree we were using before. See what happens if I select all this. In some cases, I may want to ungroup and do some of it separately, but we'll see what happens if it looks okay if I just do it all in one go. Hit calculate, and then preview. Looks pretty good to me. Not bad for 10 seconds of work.
Yeah.
Now we've got our piece of material clamped to the table. We're inside the control software. We've previously homed it, so we're going to jog forward. Now I'm going pretty quickly. There is the button in the middle here that's got a turtle and a hare. When the red light is on, it's moving in turtle mode. Red light's off, it's moving much more quickly. Alright, so we're going to jog this to the front left corner because that's where we set the datum position in the software. I'll remove the brush. That way I can see the tool, and then I'll put the brush back on. In fact, the first time we cut, we'll leave the brush off so we can watch. The brush is going to maximize the amount of dust extraction that we get. If we have them off, then more dust is getting into the room than is getting sucked up by this, but that thing's still going to suck a good amount up. I do like to have the material back on the bed a little bit because there's no reason you can't have the material all the way to the front. But when you do, you can see where the tool is relative to the front of what they call the dust shoe or dust boot. This will end up out front here, and so the extraction is happening over the opening in front, and all your sawdust is coming off the very front of the bed. So if I'm doing smaller projects, I do like to be inside a little bit because of the fact that the dust boot is going to be a little bit more effective than it would be if it were all the way in the front of the machine. We do want to be aware of the clamps and where those things are and how deep we're going, because if the bit is not hanging out far enough and it has to go deeper, it is possible that this could collide with the metal here. So we'll take a look at that before we run this job. And if that's the case, we may need to move where this clamp is or how we're clamping it to the machine so we don't have a collision while we're running. Get those there. I'm going to jog down in Z. And my goal here is to simply jog this to exactly where that front left corner is. Again, we don't have to be perfectly precise. It comes down to what you need out of the part. Since we've got a lot of room around the whole design, even if this is off by 2 inches, it doesn't really matter. We're still going to cut through the material. But again, if we're using like that example of the plaque where it's got to be perfectly centered, we need to be pretty precise with this. And there are different techniques that you can use. But for something like this, most commonly we will just look at it. I'll look left and right, so it looks to me like I should tap to the left a couple of times. And then from this direction, I'll come forward a little bit. And now I am going to zero it. There are a couple different ways to zero. If I'm in the exact position I want to be in, so I'm going to jog down in Z until I just am touching. Okay, I am just touching the corner. I can click this Set All Zero button right here. And when I do that, you'll notice these numbers up here are going to change from what they're set to 0. I've now zeroed the program position, which is different than the machine home. So program home versus machine home. The program we're about to run, I've just set this position as its home position. And now all of the coordinates that were generated when we exported the file from VCarve, those coordinates are relative to that home position. That home position is relative to the machine home position that we set when we turn the machine on. So you can see the machine coordinates are listed here. X plus 10, Y negative 89, Z negative 7. So we're 10 inches this direction from the machine home we're 89.9 inches in this direction compared to the machine home, and we're 7.6 inches in the Z negative direction compared to the machine home. You can run a job without homing it, but the problem is if the machine shuts off in the middle for some reason, we don't necessarily know how to get back to that position because we didn't tell it. If I said, you know, go a mile, well, you can go a mile in any direction and you went a mile, but if I want you to end up at the same spot, I need to tell you exactly where to go from your starting point. So I need to be able to tell the machine a position in space as its starting point or its machine home in order for it to know how to get back to exactly where I want it to get back to. So if the machine doesn't shut off in the middle of a job and you didn't home it, no big deal. But if something happens in the middle of a job and I need to find the position where it stopped again, and I didn't home it before I started it, that's when you can run into some issues. You probably lose the job and have to start from scratch. So that's why we like to home it in the first place, because that position should never change. As long as this doesn't move, every time it homes, it's going to end up in the exact same position that it was in the previous time you homed it. Does that make sense? All right, so I zeroed it in that way. Everything's zeroed, but I want to show you a different way to zero, and that's going to be using our tool sensor. Zero position for the Z, I'll plug this in here, and all that's going to happen is when the tool touches this, it completes a circuit. It knows how thick this block is, so it calculates how far away the tool is from the surface of the material. I can sit this way anywhere on the surface, assuming the whole piece of wood is flat. You can run into trouble because you've seen pieces of plywood that are really wavy. I do want to do this generally where the part is probably going to cut out to get the best accuracy. And what I'll do here is I'll jog up and Z. I'm going to turn the turtle mode off so it'll go a little faster. Jog back, jog over. And I can be anywhere over that block. I'm not going to change my XY. I still want my XY to be here. But if I want to accurately set my Z for where I'm going to cut the part out, instead of clicking set 0 all, if I hit set 0 all right now, it's going to change my program home position to exactly where the very point of the bit is. I want to do sense Z0, which is right next to that. I want to be maybe no more than the distance I am away from it right now because it will time out. I'm going to actually get a little bit closer because it goes very slowly. So you get about ½ inch away and then hit sense Z0. Press cycle start to auto set Z. Because of the fact that the machine is going to move on its own, it forces that sort of safety that you can't just hit one button. Cycle start, and there it went. Now it's saying I was 0.5 inches away when it was touching because that block is ½ of an inch thick, and then it jogged it all the way up. So it's now set my 0 for me. If I want to test to make sure that the position that I just set is actually accurate, I can use something called MDI, manual data input. This manual data input, it allows me to actually tell the machine directly G-code commands. So I can just hit X0, Y0 and enter, and hit cycle start. Now it jogged over to the X0, Y0 that we set, and now if I hit Z0, enter, it should jog it down. Now, of course, I'm being pretty confident here because you could potentially get yourself into some trouble if you got that Z wrong and you jam it into the material. But we can see it's right on the point, exactly where you expect it to start. So I do sometimes like to test that because if I hit X0, Y0, Z0 and it went somewhere else, well, I know my program's not going to be successful because the start position is not where I expected it to be. So it's a good way to verify that you did just set the job up properly. Once that's done, we'll remove this from the table. And like I said, we're going to keep the dust shoe off for now, just because we'll be able to see what's going on. One thing we do probably want to do is not assume that that tool is tight. That's how it goes flying. I don't need to leave the tool in this position. It remembers where we were. So even if I don't need to jog it to that home position before I start the job. I can jog it wherever I want and it'll know to go back there. The way that this type of router works is you've got, some of them have a button you have to hold down while you do this. This one actually just has 2 pieces here. I do tend to like to put something, yeah, that's nice and tight. That's not going anywhere. I'd put something under here because you're using both hands to loosen this, and if this bit falls out and really any distance, it's such a fine tip that you could damage it pretty easily. So I like to put maybe a piece of cardboard, something soft, so if it does fall out, then it doesn't fall and potentially hit this and break the bit. We will go through the tool change, but I don't like to assume that the tool is in there tightly before I start a job if I wasn't going to put it in last. All right, I'm gonna run this thing, so safety glasses for protection. Next step, we are going to actually load our program. So everything is set up. I'm going to go to load. And I saved this to my desktop in the CNC test files, and we're going to use the VCarve first. I've loaded the file in there, but you can't really tell. But I can go to graph, and graph will tell me the expected amount of time it's going to take, 1 minute and 34 seconds to do this. It also will show me what I'm about to cut out, so I like to do that first and make sure that the file that I think I'm going to cut is actually the one I'm going to cut. If I do need to make a change to the G code, I can click edit or hit F6 and it actually opens the G code. So if you know about G code programming, you can directly edit the file without going back into VCarve. In reality, most people don't do that, but it is possible. So this is the G code file. I can make sure that that's the right one. And then once we got that ready, it's a matter of hitting cycle start. Okay, so we're going to need to get our quarter-inch demo out, and we're going to use our key cutoff again, because while we don't need to reset X or Y, we do need to reset Z, because the tool that we put in there next is going to probably be, almost certainly be hanging out at a different length than the tool we had in there, and therefore we need to tell the machine that so it can compensate for the difference. Okay, so it didn't automatically raise it up, so we're going to do that. Make sure the hands are clear. All right, you want to change that tool out? Sure. I can draw the cord for you to make your life easier, actually. So it is nice. Yeah, and kick it over to the right. Yeah, maybe put the rag on there.
Yeah.
Yeah, it seemed like it was on there pretty tight. There's usually a second catch to keep it from dropping out, so you crack it loose the first time, and you think you can unscrew it all the way, but you'll have to crack it loose a second time, and after the second time you crack it loose, that's when the tool can come out. Now before you put that back in there, let's take a look at what's...
It's actually double-ended.
Yeah, most of them are 45 and a 60 you can usually have. So I'm going to unscrew this all the way, and we're going to take a look at this. This is... let's see, oh, this one... You can change these collets out. They pop out if you push on them, and you can see there's a little bit of buildup in sawdust. Try to get that out because the more sawdust that builds up in these, the harder it is to get the collet out. And actually, I guess maybe, yeah. So this is maybe this style you're not really needing to take these out. So you don't really need to because in many machines, it's what they call the collet and the collet nut, and those are separate things, and you keep the same collet nut and pop in and out collets, but in this case, you've got 2 collet nuts with collets preset. The difference, of course, being the diameter. So in most cases, you're using a 1/4-inch shank, but you do have a tool that has a 1/2-inch shank, and that's going to allow you to run through material a lot faster. That would be the case where I'd obviously not just change the tool, but I'd change the entire collet nut setup. We're going to stick with this one because the next tool we're going to use also is a 1/4-inch shank, but I want to show you that does come out in certain situations. So we'll just screw that back on enough that it's holding, and finish it up. So now that we've got this bit in, all we need to do is draw it back over. Make sure we're on top of the actual touch-off sensor. And if we really want to be very accurate with what it's going to be where we're cutting, we'll do it over top of where the cut is actually going to occur, because plywood can be warped a little bit, so I like to try to do it near where we're going to do it. At this point, again, I'm not going to re-zero X and Y, so I don't want to hit set all zero. That will throw everything off. I'm going to do sense Z0, and then I'm going to hit cycle start. It's going to go down and touch the tool. I can now remove this. And then I just simply need to load the next program. I don't want to run cycle start now. I'm just going to run the existing program with a different bit, and that'll be a problem. Go back to load, wherever I saved it, CNC test files. Now it's pocket 1, which if you recall, has pocket and profile. It should pocket it out, and then it should just engrave. Now I can hit cycle start. Everyone's got their glasses. Part. The primary maintenance you need to do on this machine is keep the bearings greased. On this machine, each axis has 4, so the y-axis has 1, 2, 3, 4 on the other side. The x-axis has 1, 2, 3, 4, and the z-axis has, it's actually just 2 on the z-axis, 1 and 2. This grease gun, this tip is very specific to the grease fittings on these bearings. So this is not your standard tip. There are other tips that are more common on a grease gun, and my understanding is if you use those with these, eventually it'll kind of mess up these fittings and the grease. So you want to stick with this exact setup you have. There is a little rubber seal inside of here. You can sort of see it since there's grease in there. It's hard, but it's this little black ring inside. That needs to stay in there. If that comes out, which commonly occurs if you don't get it on right, you turn it, the rubber kind of comes out and falls down, and grease will no longer flow into, it'll just come out all around the fitting. It's something about around 8 hours of use is when you should grease these, or if it's been sitting for a long time, it doesn't hurt to put a little bit of grease in. The grease that's inside of this grease gun, which I won't open it right now because it'll make a mess, but it is very important to not mix greases. Make sure it's this exact, I mean, the easiest thing to do is just make sure it's the exact type of grease that's in here already. There is a situation where if you use a different type of grease, it could turn into an epoxy, and you pump that in there and all of a sudden everything locks up on you. So just easiest thing when you run out, contact us or just Google online the exact tube that's in there and you'll be good. To grease this up, we want to get this right on the fitting, push down a little bit, and if it's successfully going in, which I want to say, shouldn't this be down? Yeah. We'll actually see the grease coming out of the bearing. If it's coming out all around the fitting itself, we're not actually getting it in. So I can kind of feel it now. See, you see right here? You'll see when I pump the next time right there. See it?
Yep.
That's how you know you're getting it in there.
Okay.
And we're just going to do that. We might as well do it on all because it probably hasn't been done for a little while. Usually a couple of pumps is all you need, but I'm just looking for that first sign that we see a little bit of grease coming out. You need to move things out of your way. Don't hesitate. Okay. And we just do this on all of the bearings. You see I didn't get this one on right, so the grease is coming out around the fitting. That is, we need to just move it slightly until you can kind of feel it going in, but it's not coming out around the fitting. and that's all you really have to do. The other stuff is keep this clean. These can rust, especially if people are putting their hands on there. It's best not to touch them, but you can kind of wipe them down, maybe put a little bit of WD-40 on there to kind of keep it from rusting if that's happening. And otherwise, it's just a matter of keeping everything that, you know, build up of this stuff in here can eventually cause issues. Clean it every once in a while. You do have these tracks under here. I have seen times where dust builds up on the tracks, and then it will
drive track.
Yeah, so you just brush that stuff off. And then the other thing is you're gonna have just your standard kind of filter there. Take that out, knock all the dust off, put it back on every once in a while, and that'll be good. That's really the main stuff on this machine. The greasing the bearings is the most important part.